Hello Dashni. So this is the second video to show you how to find the x value at which we have a discontinuity for this graph. Alright. Now I'm not going to go in detail as the other video, so we're just going to jump straight into the question. Alright, so where do we have an x value where the graph is discontinuous? Well, if you look at the graph, we're continuous everywhere until we hit x equals 7. So what happens here? We've got a jump discontinuity. So the graph goes here and then jumps and goes to another graph. So there's clearly a discontinuity at x equals 7. Alright? Now you're asked to give a reason for your answer. Now when they're asking for you to give a reason, you have to explain it mathematically to them. You can't just say, well, there's a jump discontinuity at x equals 7. So how do we prove, or how do we show that the graph is discontinuous? Okay. Now discontinuous just means it's not continuous. Okay, that's all it means. So to show that it's discontinuous, we have to show that it's not continuous. So how do we show that it's not continuous? Then there's 3 conditions that the graph has to satisfy for it to be continuous, and if it fails any of them, then we know that the graph is not continuous. Okay, so what are these 3 conditions? Number 1, for a graph to be continuous, the first condition is that f of a exists, meaning the x value that we have, if we plug it into the function or if we look at the graph, then it should exist. There should be a y value for that x value. 2, we need to show that the limit as approaching a for the function or the graph, that also exists. Okay? What does this mean? Well, for a limit to exist, we need to show that the limit of x approaching that number from the left hand side, okay, for the function or the graph, has to equal to the limit of x approaching that number from the right hand side, okay, for that function or graph. Okay, so when a limit exists, it means that the limit of x approaching that number from the left hand side equals to the limit of x approaching that number from the right hand side. And when these 2 numbers are the same, we say that the limit exists. And if these 2 are different, then we say that the limit does not exist. And the third condition that we need to have for a graph to be continuous is that the limit of x approaching a number for that function equals to the y value, okay, of that x value that we have. Okay, and if it fails any of these conditions, we have a discontinuity. So coming back to the graph, we've got a discontinuity at x equals 7. So how do we show, how do we prove that it's not continuous with these conditions? Well, the first one, does f of a exist? Okay, well, what's f of a? Well, a is going to equal 7. Does it exist? Yes, it does exist. Now, I wouldn't write f of 7 exists. What you need to do is just write the actual value, just to make it easier. So let's go up there, and if we're there, and if we come across all the way to the y value, we're going to hit it there somewhere. So what would that be? If that's 6, that's 3, so would you say 8? Just to make it easier to understand, so we're going to say f of 7 equals 8. At that point, we have a y value of 8. So we would say, yes, the first one, the first condition is are met. Alright, so what we do, we go for the second condition now. For the second condition, well, what we need to do is, for this to be true, we need to actually solve this. So we're going to need to solve the limit of x approaching 7 from the left hand side of the graph. What does that equal? Alright, so if we're coming from the left hand side this way and we're looking at this, we're approaching this value here. Okay, so what is that value? So again, if we draw a line just to make it easier to understand. So if that's a 6, what would you say? That's 5 maybe? So we can say that the limit of x approaching 7 from the left hand side would be 5. Alright, now we need to work out the limit from the right hand side. So x approaching 7 from the right hand side of the function of the graph. So what do we have? So if we're coming from the right hand side, we're coming here and we're approaching 7, we're approaching this value. Okay, what's that value? Well, we kind of guessed it would be 8 before, so we can say it's 8. Okay, so we've got the left hand side is 5 and the right hand side equals 8, and we can see that they do not equal each other. Okay, so when they do not equal each other, then the second condition has failed. So the limit of x approaching 7 does not exist. Okay, so as soon as it's failed that one, then we say that the graph is discontinuous at x equals 7. Alright, so at x equals 7, the graph is discontinuous. Okay, because the limit of x approaching 7 does not exist, and that would be our reason. Alright, that's it for this video. I hope it helped you. Do leave a comment below if you have any questions, and I'll try to explain things a little bit more clear. Alright, otherwise, good luck with your methods, and if you guys need help with maths methods and you need a tutor, then you can go to my website mathshelp.com.au and scroll down all the way to the bottom where you'll find my contact details. And good luck with your studies, and I'll see you in the next video.